Hi, I'm Callie Stroskop, and I am a site reliability engineer. This is the Deploy in Public challenge. We are on challenge number 9 of 10, which is pretty exciting because that means we are almost done. But if you haven't done challenges 1 through 8, I recommend rewinding, going on back, and rewatching from the very beginning because the challenges build on one another. If you have done challenges 1 through 8, or you just don't like listening to my advice, which is fine, that's pretty cool too, because this is my favorite out of all of the challenges. In this challenge, we are going to deploy a full stack application, front-end, API, and database to AWS using Kubernetes. We're going to be doing some of the process in an automated fashion with Terraform. So that's how we're actually going to provision our infrastructures with Terraform. But then we are going to manually use kubectl and enter our private EKS cluster to deploy the actual application. So this is going to be pretty fun. You're going to get to use all of your Kubernetes tools. And by the end of it, you'll have a full stack to-do list that you can use.
All right, so we are going to start this week off with refactoring our Terraform a little bit. The goal is to have a Terraform repo that works for either one of our infrastructures, our EC2 infrastructure, or our EKS infrastructure. Now, you could also separate these into 2 separate repos if you wanted, but I'm just going to do it this way. You're welcome to do it differently, but the goal is that you actually have Terraform code that you can reuse moving into the future, and you can pick what your infrastructure is. All right. Then we are going to create the Terraform infrastructure for our EKS cluster, and we're actually going to deploy the to-do list app that we deployed a few weeks ago with the EC2 structure. We're going to do that this time with EKS instead. All right, so let's get started. So the first thing I'm going to do is I am going to create a folder, and I'm going to call that folder modules. All right, and then I'm going to move everything that's in this folder into my modules folder. All right. So I'm just going to take ALB, move it in there. Bastion, move it in there. CR, probably be doing this more efficiently, but it is what it is. Yes, and VPC. All right, perfect. Then what I'm going to do is I'm going to create another folder, and I'm going to call this plans. All right. Within that folder, I'm going to make 2 folders. The first one, I'm going to say EC2, infrastructure. All right. And the next one I'm going to create is EKS, infrastructure. Perfect. So now I have my 2 folders. All right. So far, we only have the infrastructure for EC2, so it's going to be pretty easy. All we have to do is move our main, our secrets, and our variables file into that EC2 infrastructure folder. All right. It's mad, but it shouldn't be because I put it in there. I don't know why it's mad still. Var. Oh, all right, there we go. I just needed to change something in the file. All right, cool. So now we have this. So the way that you would create this infrastructure, right, is you would open up your terminal and you would say ls, so you can see all of your folders that you have. Then you would cd into plans. and then ls, and you'll see your 2 folders. Now you'll note that I don't have any of the Terraform state, Terraform lock files, and that's because I just started a new repo and kind of copied my files that I wanted over into it. I did it because I actually already recorded these 2 hours, but my microphone was broken in those. So I'm just kind of starting fresh. But if you have all of the Terraform state and lock files, you can go ahead and just delete those because those are generated when you create the command. So let me pull down one of my other Terraform repos so we can look, and you'll see that, right, I have all of these Terraform TF state, Terraform TF state backup, Terraform lock. I would just delete all of those, and that will be good and give us a clean thing, okay? So now let's go ahead and cd into EC2 underscore infrastructure. All right, and now you can see we have our main secrets and variables. So if we were to say Terraform plan dash var dash file, and then we were going to say secret.tf vars, you will see that we will get an error. And the reason why we get this error is because we went ahead and moved our folders and we don't have those Terraform files anymore. Those Terraform files is where we are installing all of our modules and saving our state, okay? So we have to say Terraform init. You can see that that's initializing. But something else that you will get an error on that I won't, because I forgot that I already changed this the last time I recorded the video, but let me go ahead and show you. So when we're pulling in the code for the modules, you'll see that what you likely have is something like ./VPC. So what we need to do is we need to change that. So you go up a folder. So if we go up a folder, that's going to be plans. Okay. So now we need to go up a folder again, which is going to be our DIP Terraform. And then we need to go into the modules folder. All right. So now we're in modules. Open that up. And then we need to go /VPC. Okay. And that is how you would get this. So let's go ahead and do this again. So this used to be ./IAM, which meant in the same folder that I am, but there's a folder called IAM, look in that one. But now what we want to say is we want to say // we want to go up to the plans folder, // we want to go up to the modules folder, then we want to go into IAM, nope, into modules, sorry, and then into IAM, okay? So I'm actually gonna, for solidarity's sake, nope, we'll just continue. All right, so this would go from /bastion to that. Make sure you change your ECR as well, your RDS, your private EC2, and your ALB. But all of them, because you're in the main file in plans, all of them will be // modules / and the name of the module. Okay, perfect. So once you have that, then you can go ahead and Terraform init. And if you see this Terraform has been successfully initialized, then yay you. All right, and then you can say Terraform plan. Now, I'm not actually going to, Terraform plan var file secret.tfrs. I'm not actually going to deploy this, but this is going to be helpful to us to figure out if we have any errors. So you can see that we are calling, or we're saying that for the user data, we want to run the script that's in this called docker.script that's in the same folder, but now you can see it's not in the same folder. So we actually can just move that into there. All right. You'll see too that now we have our .terraform folder and our lock and that is going to be what. And then when we actually create something, then we'll have the state too. Oh, see, it popped up for a second. All right, so now we have no errors. We have 49 resources to add, 0 to change, 0 to destroy. All right, so now we are going to create our EKS cluster and the node group. Now, last week we created those manually in the console. So we're going to actually use the console to help guide us in how we're going to do this, okay? But the first thing that we need is we need a main.tf. All right, and the next thing that we'll need is we'll also need the same secrets.var because we still have a database and password. So we'll put that in there. And we will also need a variables. All right, let's look through the variables and see what out of it we need. All right, so yep, we'll still have region. We'll need the CIDR block for our VPC. We'll need the public and private subnet CIDRs for our VPC. We'll need our app name for pretty much every module, and then we'll need variables for the DB username and password. So that is pretty perfect, okay? We don't need a Docker script because we aren't going to be installing anything on the EC2 instances that we make because Kubernetes is going to do everything that it needs to be done for us. All right, so let's go ahead and open up this main. We are going to go look at, where's my terminal? Oh yeah, I started a new repo here. All right, so we are going to go look at this step-by-step guide, creating an EKS cluster with Terraform. Now they are creating a little bit more than what we will need to create, but this is actually a really good guide. So I would jump between this and the console and also the Terraform registry. Okay, so see how they're creating the VPC. We are not going to create the VPC, but that is okay. So here we'll go down to where we have to create the EKS cluster. So what I'm going to do is I'm actually going to go to the EKS service and take a look at the console to remind myself of what we needed to create. So when we created, we needed a name, the version, and then if you remember, we needed a IAM role for our specific EKS cluster. So that's where we're going to start. Because we need a service role in order to create the cluster, it makes the most sense in my head and in this tutorial to create that role first. Okay? So let's pull this over like that. All right. So if we remember, we have other IAM roles. So what I'm going to do is I'm going to just go ahead and kind of copy an IAM role and a policy attachment from our IAM module. And then I'm going to paste it into our EKS infrastructure. And then I'm just going to edit it because you can see that we actually it looks like we're kind of doing the same thing, but I just want a consistent way that we're doing things throughout the entire repo, and there are a little bit of differences in how you can attach these statements. Okay, so this is not going to be our EC2 role, this is going to be an EKS role. We'll name it, this is going to be coding with Callie, so then we just want to say coding with Callie EKS role. All right, that's the role for the node group. Did I go too far? Oh, here, yeah, IAM role for EKS. So yeah, see how the policy is like written with these. I like with the JSON encode instead. Okay. So we are going to have an EKS role. I think I want to write this actually as EKS cluster role because we're going to have a node group role as well. All right. So here, if you remember, when you go and create, so let's go and create an IAM role in the console, you have to select a service, right, that you're going to allow to perform actions. And so the service that we're selecting is EKS. So it's not ec2.amazon.aws.com, it's EKS. All right. So we're basically then now going to attach policies that we're saying that our EKS cluster can do. All right. So let's take a look. So they named it, they added tags. I'm not going to worry about tags, but yep, for service, they changed that to EKS and then saying assume role. Next, they're attaching their policies. So if you remember, so if I go and click next over here, now you can see the policies that the EKS cluster, or the like permission policies that EKS cluster can do. So let's open this up. And this is you can see that we can do auto scaling and then a bunch of different things in EC2, elastic load balancing. All right, so we're giving our cluster the ability to do all of these things. All right, so we need to attach this policy. So instead of saying that the role is the EC2 role.name, we are going to say it is the EKS cluster role.name. All right, and then here we are going to change this to Amazon EKS cluster policy. All right, so it's going to create the role and then it's going to attach this policy to it. I'm also going to change the name here because this is saying SSM policy. I'm going to change this to EKS cluster policy. I'm actually going to leave attachment out because technically attachment is here, okay? Which I guess on that same note, we could do this, right? So we're creating a role for the EKS cluster, we're creating an attachment, and we're attaching the EKS cluster policy. So then we need to change this. All right, perfect. So now we have our IAM role for our EKS cluster, and then we have the policy we're going to attach. So what do we do now? If we look in our folders, right, we are currently in the terminal in the EC2 infrastructure. So we need to go out one file, so cd //. All right, so now we're in the plans folder. And then we need to go into, so cd EKS infrastructure. All right, and now we're in the EKS infrastructure folder. Just a note when you're in the terminal, if you're referring to like a directory or a file, if you start writing like what it is, so let's say CD and then EKS, well, there's no folder called EKS in there, but let's say I was in plans and I said CD. If I were to say tab, nothing would happen because there's two directories that start with E. But if I say EC and then tab, it would auto-complete this because there's only one directory that starts with EC. So it's a way to quickly do something. All right, another thing is I've been typing clear in my terminal in order to clear the terminal. Another option for that is going to do the Control L. All right. So now that we're in the EKS infrastructure, we can do Terraform plan. All right, it's going to ask because I always forget -var -file secret.pf. All right. All right, so we need to do Terraform init first, which makes sense. We were expecting that. Created our .terraform plan for us. And then it's early. Then after we did the init, which installed all of our providers, we can then do the plan. All right, and you can see that it is all set to add our cluster role and attach the policy. So I'm actually going to apply this. Because why not? And you can see that state file popped up, right? Perfect. And now if you go back over here to this create and refresh, you'll see that now we have an Coding with Kali EKS cluster role that we can use to configure the cluster. Perfect. All right, the next thing that we're going to do is now that we have the policy, we can actually create the EKS cluster. So I'm going to go tap down here and I'm going to say resource, AWS, EKS cluster. And then we will say EKS cluster, which is probably a bad name, but this is, so is life. Okay, so name. Yep, we'll do var app name, which is going to be coding and Cali dash EKS cluster. And then, yeah, role ARN. Let's type this out though. Let's get the AWS underscore IAM role dot EKS cluster dot ARN. Perfect. All right, what else do we need? It looks like we need a VPC config. So let's add that, VPC underscore config. And then we need to add in subnet IDs. All right. And for this, we are going to use our private subnet IDs. Okay. However, that means that in order to use our private subnet IDs, we need to get those from our VPC. So now it's time to add in our VPC module. So the way I'm going to get it is I'm going to go to my main EC2 infrastructure. And I'm actually now, I think it's time to just copy over everything that we need. So yes, we need our VPC. Yes, we need IAM. Yes, we need Bastion. Yes, we need ECR, front end and back end. And yes, we need RDS. We do not need our private EC2, and we do not need the application load balancer. All right, so now that we have all that, I can go ahead and paste that in here. All right, and instead of var.private subnet IDs, we can use module.vpc.private subnet IDs. All right, did I do that right? So module.vpc.private subnet IDs. All right, that looks right. All right. VPC config here. I'm going to just copy this. I'm doing something wrong. All right, and then module.vpc.private subnet IDs. All right. Terraform's weird sometimes. All right, so that should be pretty good. We're going to add this depends on too. So the depends on is just going to make sure that our IAM role for the EKS cluster has already been, we want to do the attachment, right? We want to make sure that yes, our IAM role policy attachment has been done. So we want to make sure that the role's been created and then we've attached the policy to that role before we create the cluster, all right? Which we have because we already created it. But now that we've done that, we can go ahead and Terraform apply. You can see that it's now like, hey, wait, you got to install all of these other modules, which fair. All right, so let's go ahead and do Terraform init. Perfect. Okay, so we need to do Terraform init upgrade. You can do it, Terraform. Perfect. And then let's try, sure, we'll just try to apply it. You can see that we get an issue. All right. So the issue that we get here is that we are saying that our security group for RDS that we're pulling in is from our private EC2 module. Right? So if we go up, you can see that it's pulling in the private subnet. Now,
eventually we will have a node group, and the node group is essentially just EC2 instances, right? So essentially we will, in this spot, oh, that's private subnet IDs. Sorry, this is what I'm talking about. So eventually in this spot, we will say that our private security group ID is going to be the security group ID of that node group. All right, but we don't have that right now. So what I'm going to do is I'm just going to go ahead and comment this out, and then we'll try again. All right, it's going to create 27 resources. Let's make sure it is including an EKS cluster in that. Apparently it's at the very top. Geez, oh Pete's. Yep, and here's our cluster. All right, that looks good. So I'm going to go ahead and say yes to that and let it go ahead and create. All right, while that's creating, I'm going to go ahead and pause here because you don't need to sit and wait and watch all my resources get provisioned, but I will be back when they are. All right, so our EKS cluster has been provisioned. Let's go take a look. And yay, we have a cluster, but you'll notice that in terms of compute, we have no nodes. Boo. So we have to add a node group. Cool, cool. All right, let's go now back to our step-by-step guide. All right, and we're going to scroll down, and now we have our role for our node group. All right, so I'm going to go back here, and I'm going to copy my Terraform code for an IAM role and a policy attachment because I'm going to edit it. All right. So for here, this is going to be my IAM role for my EKS node group. So instead of EKS cluster role, it's going to be EKS node group role. All right. This is going to be EC2 because my nodes are EC2 instances. All right, and then we are going to attach policies. All right, so this IAM role is going to have 3 policies attached to it. The EKS worker node policy, the EKS CNI policy, and the EC2 container registry read only. So let's go ahead and type that out. All right, so this is going to be EKS node policy. Sure, we could add node group. That's fine. And that's going to be Amazon EKS worker node policy. All right, but that will not go to the EKS cluster. That will go to the EKS node group. All right, roll. Let's copy and paste this. So here now we don't want the node group policy. We want the EKS CNI policy. Yep, we want to attach this policy to our EKS node group role. And then let's go ahead and EKS CNI policy. Perfect. And then let's copy this and paste it down. This policy that we're going to have is going to be the EKS ECR policy. We'll still attach it to that EKS node group role. And then let's change the policy that we're attaching. And yep, Copilot is correct. It should be the Amazon EC2 container registry read-only policy. All right, so now we have our node group role and we've attached the necessary policies. All right, let's move on to our node group.
All right, so you can see that this one's a little bit longer and more involved. That's okay. Let's just go through it step by step because we won't need all of them. We're going to go with kind of a simplified version. So let's create the resource. We need an AWS EKS node group. And then I like the name private nodes. All right. We need a cluster name, and that is going to be correct. So this node group goes into our EKS cluster that we created above. All right. Looks like we also need a node group name, which yep, coding with Kali, private nodes works. Then we need a ARN for it, and that's going to be our IAM role that we just created. Subnet IDs, yep, we're going to create them in the private subnet. So that works. And then we're going to have instance type. I am going to change this to medium because that's the default. Do we need medium? Probably not. Actually, like pretty sure we don't, but I'm just going to follow with the defaults on here. Okay. And we shouldn't need capacity type on demand, so I'm going to skip that. And then we do want the scaling config though. So I'm going to go ahead and put that on. I'm going to say that our desired size of our node group is 2, max size 2, min size 2. So that's going to create 2 EC2 instances in our node group. All right. And then let's add our update config. We're going to say the max unavailable is 1 node. So that way we always have 1 node working because we'll have the max size of 2. All right. We then are only going to add our depends on, and that's going to be the depends on the creation of each of our policies. So we want to make sure our node group policy, our CNI policy, and our ECR policy are all, this should be depends on, are all attached to our IAM role for our node group before we create this. All right. So that looks good to me. Let's go ahead and Terraform apply. I have to add 2 to change, to destroy. All right, we'll say yes. Perfect. So while that's creating, now we need to go and think about what additional security rules we need, right? So when we create this EKS cluster, all right, what do we need to make sure can communicate with it, all right? And that's going to be that we, in order to actually use kubectl and configure the resources on our Kubernetes cluster, we need to have the bastion host have access to the EKS cluster, all right? And that's going to be through a security group ingress rule, all right? So we need to, and I'm just going to make a comment for this, all right, add a security ingress rule. So Bastion can communicate with EKS cluster. Okay, so it's going to be one of the things that we want to do. All right, the next thing that we want to do, if you remember up here, we commented out our RDS cluster. And we commented that, or RDS instance, sorry. And the reason we commented that out is because we needed the security group for the EKS cluster in order to say that our EKS cluster is allowed to communicate with our RDS instance. And just in case you forgot, let's go into the RDS module here and take a look. All right, you can see that we have an ingress rule allowing traffic into the database from our private instances. And the way that we do that is by we attach the security group of those private instances, so that way they can communicate with the RDS cluster. Before we created the cluster, we had no idea what the security group is. And to be honest, we didn't make a security group for the EKS cluster, so it's a little bit confusing too. So the next thing that we'll need to do is figure out how to get the security group ID of the EKS cluster. That's perfect. And the next thing that we need to do then is we need to comment back in the RDS module and add the security group ID of the EKS cluster. The EKS cluster security group is created for you, and you can actually get it by following this. So it's EKS cluster, cluster name .vpcconfig 0.cluster security group ID. All right. So knowing that, we can now fix these two here. Okay. So we're to comment back in our RDS cluster. All right. And then where we have the EC2 security group, we're going to get rid of that. And we're going to say AWS _EKS cluster .EKS cluster .vpcconfig at 0.security, .cluster security group ID. All right, and so that should allow us to now create our RDS cluster and make sure that our EKS cluster can communicate with the RDS cluster. All right, so that gets those two out of the way there. The next thing that we need to do is add an ingress rule so that Bastion can communicate with the EKS cluster. All right, so the way that we do that is we say resource AWS security group rule, Bastion ingress rule. I'm going to change this to allow Bastion ingress to EKS cluster. All right. And then we need to say, type ingress from port to port 443. Sorry, sometimes Copilot is nice and sometimes it just adds a lot. All right, so we're going to say type ingress is fine. So from port is going to be 443 because that is the HTTPS port and that's what EKS is running on. To port 443, perfect, protocol TCP. And then we want to say that the security group ID, and I'm actually going to add it up here. So our security group ID is, going to be our module.bastion.security group ID. And then we're going to say our source security group ID is, AWS EKS cluster.EKS cluster. And then, .vpc0.cluster security group ID. Perfect. All right, so now this adds our security group ingress rule for our Bastion host. All right. So the very last thing I'm going to do before I Terraform apply this is I'm actually going to create an EKS module. All right, so let's go into our modules folder. Let's create one and we're going to say EKS. I should be able to just copy this main file. No, I'm going to copy because it has all my modules. I'm being silly. All right, I should be able to just cut all of this out there. And then I'm going to go to my EKS folder and I'm going to create a main.tf. All right, and then I'm going to paste in all of my EKS resources. All right, you can see that I'm already getting some errors and I let my errors tell me what I need to work on. All right, so I need a variable for app_name. And that is going to be type string, and then the description will be, our value of our app name. All right, so that solved that issue. So let's keep looking through. All right, here we are referencing the VPC module. So instead, we need to change this into a variable. So variable private subnet IDs. Let's go back here and then add that variable. So variable private subnet IDs. And yep, a list of strings and value of private subnet IDs. All right, perfect. The rest of this so far is looking okay. All right, here we have the private subnet IDs again. So I'm just going to use our variable instead. And then here we're using the bastion module. So we're going to say var.bastion. I like that security group ID. And then let's add this. So variable bastion security group ID. All right. Let's keep going. And everything else looks good. All right. So let's now go and add the module. So we're going to say module EKS. And source is going to be from that EKS folder in our modules folder. And then app name is going to be app name. Private subnet ID is going to be from module.vpc.private subnet IDs. It's correct. And our bastion security group ID is going to be from module.bastion.security group ID. Perfect. That all looks great. You'll notice though, if we try to apply, we're going to get an error. First, we're going to say that we did not init. So let's do Terraform init. All right, now let's try to apply and let's see what gotcha we have. And here we're referencing our AWS EKS cluster, but we just modularized that. So now we need to add an output. So outputs.tf, and we're going to say output EKS security group ID. Nope. And the value is going to be AWS EKS cluster .EKS cluster .vpc at 0. Perfect. That looks good. All right. So now we have our output. All right. Let's go back to main. And here we are going to call this module.EKS .EKS security group ID. Perfect. All right. So now let's try once again to apply and see what happens. Looks good so far. Yes, we want to add this, and this should now add our ingress rule in our RDS cluster. All right, that's going to take a while because RDS, let's be real, takes a while to create. So I'm going to pause this and I will come back when it's all created. Blah. All right, so we got these errors. So basically when I moved folders, I probably shouldn't have done this at this point because moving it into the EKS module means that it then wanted to go and delete our cluster in our node group and then recreate it. And then now it's trying to create IAM roles. So I just kind of messed everything up. So I'm going to go into my IAM roles here and I'm going to manually delete the ones that it's mad at. Which lies. I don't see it. Did it delete it? All right, let's see. I'm running Terraform apply again. But moral of the story, maybe don't move it. Or we're just getting really good at Terraform. That's the moral of the story, right? All right, so see now it's, okay, it looks like the IAM roles got created fine now. And now it's creating my cluster and my node group. Let's go check on, I think it already created my RDS cluster or my RDS instance. I keep saying cluster because at one of the companies I worked at, we actually did database clusters and then an instance inside it. So I'm just used to saying that. All right, so yeah, we do have the RDS up and running now. Looks like we're just creating the cluster and the node group then. All right, so I'm going to repause and then I will just come back for a second, hopefully, to say everything worked. All right, so everything is added. Let's just go take a peek around. Let's go to clusters. And yep, we have an EKS cluster. And then if we look, we have our node groups and they're both ready. So that's good. Let's go take a look at our bastion host. I have our bastion host and our 2 nodes. You can see that those are still, oh, they're coming up. All right, let's go and look at that EKS security group. Make sure that that allows so we should have a security group from the bastion host. And we do not, so we might need to take a look at that. Let's look at the RDS security group. All right, so the RDS looks good. We have the bastion host and the EKS cluster. Let's look at our Terraform code. var.bastion security group ID. Oh, and it's because we have it switched, right? So this should actually go here, and this should go here, right? So the security group that we're editing is the EKS cluster, and then the source security group ID, let's just is that. All right, so let's go ahead and take a look at that. Always good to look at your console and make sure you didn't mess up anything. Clearly, I was typing too fast. Let's see what it's going to destroy. It's just going to replace the rule that we made. But if you're ever confused about if something got applied correctly, just go take a look. All right, so now you can see that we have ingress into our EKS cluster from our bastion host. All right, now that we have our EKS cluster up and running, we are going to go ahead and configure kubectl so that way we can deploy our application. All right, so this is what we need to do first. The first thing that we need to do, also just a note, I'm going to go through this a little bit quicker than I did last week. If you need more support than what I'm about to give, it's totally okay. This is a confusing thing, but jump back to last challenge and try to use those as your guide. All right. So the first thing that we want to do is we want to change our etc host file. So I'm going to say sudo nano/etc/host. I'm going to type in my password. And then you can see that it's kind of getting messy here because I didn't clean up after my last cluster. But the point of what I'm doing here is I want to say when I try to hit the endpoint for my EKS cluster, I want to be redirected to my local host, 1.27 or 127.0.01. So let's go to the overview. Let's grab this API endpoint minus the HTTPS, and then let's paste it in this etc host file. You'll do Control X and then yes to save. All right, and that is the first thing that you need to do. The next thing that you need to do is configure your kubeconfig file. So we need to do AWS EKS update -kubectl config. Then you need to do -- region. For me, that's US East 1. And then -- name, which is Coding with Kali, EKS Cluster. That's going to go communicate with the EKS and configure what our current cluster is with our kubeconfig file, which you can see right here. All right. So now let's go ahead and open up that .kube/config file. And we need to find the server line. And then for that line, we need to add a port onto it. And why are we doing this? Well, so I'm using 3443, which is just adding a 3 before the port that the EKS cluster is on, which is 443. That's just the port for HTTPS traffic. All right. And I'm doing this because when I type in kubectl get nodes, what it's trying to do is it's trying to hit this endpoint, all right, here. So the first thing that I did by changing the host file was by saying, if I'm trying to hit this endpoint, redirect me to 127.0.0.1, which you can see here. It redirected me here. The port comes in because we want to say that we want to redirect us to localhost at the port 3443. All right. The reason why the connection is getting refused is because we have nothing listening on localhost at that port. So that's where the third part of the puzzle comes into play. So we want to use port forwarding with Sessions Manager in order to get this done. All right. So we're going to go ahead and grab this whole line here, Control-C and Control-V. All right. Then I'm going to go in and delete the host here. All right. I'm going to click Control-A to jump to the beginning of the line or the beginning of the command. So I have to scroll less. Slowly but surely learning some terminal commands. Then I'm going to go to EC2. All right, and I'm going to get my Bastion host instance ID. Oops, and I didn't do that correctly. Sorry, I forgot to put in my EKS cluster endpoint. So let's go to EKS. And let's grab this endpoint here. All right, and then we need to fix the ports too. Clearly, it's been too long of a day. All right, so 3443 is going to be our local port number, and then 443 is going to be the port number for EKS. Now we should be able to start our session, and it's waiting for us to connect to it. So I'm going to open up a new terminal tab, and then I can type in kubectl get notes. What's that doing? It is when we use kubectl, it's looking at the kubeconfig file. It's seeing that the server endpoint for the kubeconfig file is this endpoint here at port 3443. We have a redirect configured on our etc host file that says that if we try to hit this endpoint, it's going to redirect to local traffic. So when we type in kubectl, what we're really doing is we're hitting localhost at port 3443. We have a listener waiting for connections here to forward any traffic that we have at localhost at port 3443 to our EKS cluster at port 443 through our Bastion host. And the reason this works is because we have the security group on the Bastion host or on the EKS cluster that allows ingress from the Bastion host. All right, that was a mouthful, but now that we have kubectl configured, we can get to work and start deploying our application. All right, so now that we have everything set up, we are ready to deploy. So we are going to, in this video, create our Kubernetes deployment for our API. All right, and so go ahead and use the example YAML file. So to clarify, last week, the
terminal and used like different shorthand commands that you can use in the terminal to create deployments, services, and pods. All right, and that's awesome because it's super quick. So when you use the terminal,
It's quick, that's handy, but there's also a downside, right? It's not as maintainable because you don't have a YAML file for you to go look at and make small edits. And also it's not like replicatable, whereas like with this, right, I can push to GitHub and eventually, aka next week, we can have it automatically deployed. We can make a quick edit, push it again, all right? So it just kind of depends on what the context and situation you're in as to whether or not you want to create commands in the terminal using kubectl to create your resources, or if you want to use a YAML file. Typically, you're going to use a YAML file, all right? But if you're doing something like the Certified Kubernetes Application Developer course / exam, you'll want to get good at using the terminal. That aside, let's dive in. All right, so I am going to first create a new branch for my repo because I have this beautiful GitHub Actions workflow that works with my EC2 deployment. And I like that, so I don't want to do anything, break it, right? So I'm going to check out a new branch by saying git checkout -b, and then I'm going to call it EKS. And apparently I already have one that exists. So we're to say EKS Fullstack. All right. I then just like to immediately push once I create a new branch, but you don't have to. When you're creating a new branch for the first time, it's going to give you this comment to basically set this same branch upstream in your origin, aka in GitHub. All right, so we'll go ahead and run that. If I go back to my Chrome and I refresh, you'll see that I have EKS Fullstack. You'll also see that I've made a lot of branches and I'm not doing a great job at being clean with my code. All right, so I'm going to go ahead and clear my terminal. All right, so now that we're on a different branch, anything I change here is not going to mess things up. So the first thing I'm going to do is I'm going to change this command to on push. In the branches, I'm going to change this to EKS Fullstack. So when we push that branch, it will automatically set off. Oh, and it's a dash, not an underscore. It felt weird when I was typing it. All right, so when I push to EKS Fullstack, the branch that I'm on, this will automatically deploy. So let's think this through. What do I want to happen when I push? I'm going to be creating the deployment and the services manually, but I still need a Docker image. So I'm going to leave up build API, all right, because I still want my image to be built for the API, and I still want my front end image to be built as well and push to ECR. The things that I don't need is deploy API and deploy front end. And the reason for this is because both of those are deploying to our EC2 instances, and we don't need to do that. All right. So we are going to just leave for this week, we are going to leave our jobs as building and pushing to ECR, and then the rest of the task we will do on our own. Let's just first take a look at what secrets and variables are being used, because we want to make sure that we don't need to change anything on GitHub in terms of secrets and variables. All right, so I have access key and secret access key. Those should be fine. Region should be fine. The image repo should be fine because I named it the same thing on Terraform. And front end image should be fine. All right, perfect. That all looks good. So what I'm going to do then is I'm going to get status. Perfect. That's the only file I'll change. So I'm going to go get add, get commit, and then I'm going to say removed deploy jobs from workflow. And then I'm going to push that to GitHub. All right, so now if I go to the Actions tab, you can see that my building of my Docker images jobs are kicked off, and both of these are going to be built and pushed to ECR. Then we will go ahead and manually pull from ECR and create our deployments and services. I'm going to go ahead and end the video once this is done pushing, and we'll start fresh in a new video. But let's just go ahead and head over to ECR so we can verify that everything got built and pushed correctly. You can see I have 2 repositories here. Our front end looks like it's done. So let's go ahead and look. And yeah, we have an image with the tag latest. And then this one is still spinning. Now it is done. So if we go and look, we have one with the tag of latest. Perfect. Now we are finally onto the fun stuff. So what I'm going to do is I'm going to create a folder and I'm going to call it K8. All right. And this is where I'm going to put all of my manifest files. A manifest file is basically just the definition of the resources that you want in your Kubernetes cluster. All right. In YAML, yeah, another markup language. All right. So I like to keep them all in a K8 folder, and I like to have some folders inside. The first one I'm going to have inside is called API. All right, so that's going to include the deployment and service YAML files for my API. The next I'm going to have is front end. All right, and that's going to have the deployment and service files for my front end in it. All right. I think the front end is going to be an easier of the 2 to deploy and create the deployment file for. So that is what I'm going to start with. I'm just going to call it deployment.yaml. So now we have a YAML file and it's blank. The easiest thing to do is to head to the Kubernetes docs, and they usually have a pretty simple first YAML file for each of the resources. We're not really doing anything crazy with the application that we're deploying, so it makes sense to use something simple. And you can always add from it. All right. So we copy it in. A deployment has, or pretty much any resource in Kubernetes, the YAML file is going to have 4 main, like top tier level properties. Okay. We're always going to have, so if I condense these are the 4 that we're always going to have. API version, and that is just going to be something that you look up on the Kubernetes website. All right. Deployments, for example, are part of the API version apps/v1. Kind is the next thing. It tells Kubernetes what resource we are trying to deploy. And here we're trying to create a deployment. Then we have metadata, which is like the metadata about the resource. So something like name, annotations, and labels. And then finally, we have spec, which is our specifications. All right, this is kind of like the meat and potatoes part of it, where you tell exactly how it's going to work. All right, so let's kind of take a look. API version and kind will stay the exact same. Metadata, we're going to change. So this is not going to be an Nginx deployment. No, it's going to be a to-do dash front end deployment. All right. The labels then that we're going to use is app to do. Nope. Come on, Copilot. And then we're going to say tier front end. All right. So what are labels? Labels tell us are attached to the resource. So the first thing that they help with is querying our resources. So right now we're deploying one app. That's not really a lot of resources. You can probably keep track of it in your mind / see all of the resources quickly on the terminal, right? By saying kubectl get pods. We're only going to have a few pods. It's not going to be that complicated, right? But what if you are working at a company and you have thousands of containers running, thousands of pods and services and deployments and whatever, right? You want to be able to query and search specifically by what you want. So the first thing that labels are helpful with is being able to search your existing resources. I could create a query that says, hey, I want all of the pods that pertain to the app to do. For us, that would bring us a front-end pod and an API pod and our database migration pod, all right? Then let's say you want to look at just the front-end pods. Let's say you have 10 applications though. You would see all of the front-end pods for all of those applications and so on. You could also use environment for this is too. All right, spec, our specifications. All right, so the first, you'll see two specs. The top level spec in our deployment is specifications about the deployment, okay? So we want, in this deployment, we want 3 replicas, all right? So I don't actually want 3 replicas. I'm fine with just 1. So I'm going to change that to 1. It doesn't really matter though, because we have a pretty large EC2 instance and we have 2 of them. So I guess we could do 3. And then the selector is going to give you the labels that this deployment will select, that the pods it selects will have. What does that mean? That means that this deployment, okay, I'm going to say that the pods within this deployment have to match app to do and tier front end, okay? So then this is a good way for basically the deployment to select its pods, all right? If the selector is a little bit confusing, that's okay. It'll make more sense when we look at service. Then this next section here, template, is going to be the template of the pod that goes within this deployment. So let's say we had replicas at 10. It's going to create 10 pods with this template. All right. So we already said that we want to use the selector. We want to say that the pods that are in this deployment have to match the labels app to do tier front end. So we need to add that to the template, app to do tier front end. All right. That's going to be the metadata. Then we have to add a specifications for those specific pods. Okay, so in those pods, we're going to have one container. The name of the container could be to do front end. All right, and then the image is not going to be Nginx. The image is going to be from our ECR repository. We're going to get the URI here, and we're going to put the image, and then we're going to add the tag latest. All right. For here, ports, our container will run on port 80, so that's actually perfect. We don't need to change that at all. All right, so now that we have the deployment, let's go ahead and try to create the front-end deployment resource. All right, so we could type in kubectl, but you'll notice as you start doing this over and over and over, typing out kubectl is really tiring. So we should set up an alias instead. So I'm going to say alias k is equal to kubectl. All right. So now instead of kubectl get pods, I can write k get pods. All right. It looks like my session ended here. Let's restart that. And we have no resources found in the default namespace because we didn't deploy anything yet. Let's try it. So what we need to do first is we need to ls so we can see what our directories are. We want to cd into the K8s folder. And now we have API or front end. So we're to cd into the front end folder. And then we have a deployment YAML file. So we want to either say K or kubectl create -f deployment.yaml. All right, if it works, we'll see this line that's saying that our to-do front-end deployment has been created. All right, so let's take a look by saying, well, first I'm going to clear with Control L, then I'm going to say k get pods. And you can see that I left it as 10. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pods for our front end. Okay. So let's go ahead and create a temporary pod in order to be able to ping and make sure that the deployment works properly. I'm going to get rid of my nav bar here because it's taking up some room. But let's go ahead and say k get pods -o wide so we can get the IP address. All right, Let's expand this even more. Right, so here are our IP addresses, okay? And you can see that they're spread over our 2 different nodes as well, which is pretty cool. So let's go ahead and create our temporary pod and give it a try. So we're gonna say krun temp pod. This is a good example of when we wouldn't need a YAML file because it's easier to do in the terminal. All right, -- image nginx -rm -it -sh. Just dash, nope, -- space sh. All right, so now we can say curl, and then it doesn't really matter which one we select. And we can see the React front end. All right, now it's time to create a service. And why would a service be important? Well, you can see here, the key aim of services in Kubernetes is that you don't need to modify your existing application, okay, in order to communicate with your pods. All right, so if you're using a deployment to run your app, that deployment can create and destroy pods dynamically. From one moment to the next, you don't know how many of those pods are working and healthy. You might not know what the healthy pods are named, okay? Why is Kubernetes destroying and creating your pods? Like we saw last week, it could be scaling up / scaling down, all right? And for any given deployment in your cluster, the set of pods running in one moment could be different than the set of pods running in the next. This leads to a problem. If some sets of pods provide functionality to other pods, how do you know that the front ends find out and keep track of the IP addresses? So this is the reason behind services. Services select pods, and I'm using selector, right, on purpose, all right? And then when you hit the service, instead of hitting the pod directly, the service forwards the traffic to your pod, all right? So let's go find an example simple service. This looks like one right here, all right? And we are going to create our service.yaml file. Let's go ahead and paste this in. Once again, you see the 4 top level properties: API version, kind, metadata, and spec. All right, so for service, the API version is v1, the kind makes sense as service, the metadata. So instead of calling it my service, we're going to call it to do front end service. All right, and we might as well add labels. So I'm going to say app is to do, tier is front end. All right, that will help us search things more. The spec then, again, is the specifications of our specific service. So our service is going to select pods that match with the labels app to do and tier front end. All right. And the ports, we will use the TCP protocol. Our port will be 80, and I'm going to make our target port 80 as well. All right. So let me go ahead and just have Copilot explain this because I'm starting to get confused as to what port is what. So let's take a look. This line of YAML you provide is typically found within a Kubernetes ingress. Oh, sorry, I was looking at the wrong one. Okay, so port, this specifies the port that the service will expose. Okay, so our service, that makes sense. And then target port 80 is the pod. Okay, that's what I thought, but the way it was written kind of confused it. The ports that they chose were kind of confusing to me. Anywho, so this port here, 80, is the port of the service, all right? This port here is the port of the pod, all right? Then if you look in the deployment, this port here is the port of the container, all right? So I like to keep them all the same. Sometimes this might not be possible though. Like let's say you have two containers running on port 80, you're gonna need a differentiation or 2 pods, whatever. You know what I'm saying, hopefully. Maybe, I don't even know what I'm saying. All right, so this is our service. All right, if you don't include a type property, it's just going to be cluster IP, which is the default, which means that you can communicate with your service from inside your cluster. All right, so let's go ahead and ls. You can see a service.yaml file is now in there. So now we can say k create-f service.yaml. Woohoo, and that went ahead and created. So now I'm going to once again run my temp pod. But first I want to make sure that the service works. So I'm going to say k get service. All right, you can see a bunch of two services popped up, but let's say you had thousands of services. This is where you would use labels and or namespaces, which we'll go over in a little bit, to sort and make it easier for you to view what you want to view. All right, so there's our service. It looks good. So now let's do k run temp pod --image nginx --rm -it --sh. Now we can say curl to do front end service at port 80. You can see that now we see our React page. We don't know what pod that came from because we're pinging the service, and then the service is looking at all pods that have app to do and tier front end, and it's going to send it to one of those. All right, now that we have our deployment and service YAML files for our front end, hopefully this will be very quick to move into our backend. So I just copied and pasted them, and then we're going to go ahead and edit them from there. Let's start with the deployment. All right. So API version, kind, metadata, and spec. Version and kind will stay the exact same. We want to create a deployment. Here, I want to change the name from to do front-end deployment to API deployment. All right, the labels that I'm going to have is app to do tier API. Sure, we can do replicas 10. It's a little silly. Actually, let's do 3 replicas for the API. All right, and for the selector, we want the pods to match the following labels: app to do and tier API. And then the template that we're going to use for our pod has to have the same labels that are in the selector. So we're going to have app to do, tier API. And then in our spec, we're going to have to do API. And we have to go to ECR to get the correct repository URI, which is going to be here. So paste that in. If we can go ahead and make this bigger. And then we're going to say latest is the tag. Now, we don't actually have to include latest because if you don't include a tag, it automatically includes latest, but I'm going to include it because soon we're going to use versions instead. And when we start wanting to use versions, I don't want to forget that we need a tag there. All right, and then this is running on port 3000. Perfect. All right, so we have this here. What I also want to do is I want to change my deployment for my front end to have 3 replicas as well. And I'll show you how we would do this. All right. So let's edit our front end deployment first. So we're to say k kubectl apply -f deployment.yaml. All right. When we use apply, oops, sorry about that. There we go. When we use apply instead of, so we use create if the resource doesn't exist yet. We use apply if we're updating changes. All right, so you can see that it's supposed to have this annotation here, but it went ahead and added the missing annotation for us. And now you can see that the front end deployment was configured. We can check this out by saying kubectl or just k get pods. And you can see that now we only have 3 front-end deployment pods running. All right. Now, we need to get into our API folder now. So we're going to cd right? We're in the front end. We need to get out of it by doing .. Now we're in our K8s folder, so then we can do /API, and now we're in the API folder, and you can see we have a deployment.yaml and a service.yaml. So we are going to say kubectl, or we could have just said k create -f deployment.yaml. And our deployment was created. All right, I'm going to clear my terminal with Control L, and then I can say k get pods. Now you can see that we have 3 running front end pods, and then we have 3 pods that are getting created. Ooh, and we see that we have a restart because we forgot some stuff. All right. So this is good to notice. If you are seeing your pod restarting, especially super soon, your first step would be to k get pods. Take a look, and you can see run, error, multiple restarts. The next would be to look at the logs. So we're going to highlight this, grab it, paste it in, and you can see what the logs are. So this one's trying to run the migration. So this should ding in your head that, oh crap, we're supposed to be passing in environment variables. Let's go ahead and look at the logs for one that erred, and you can see that we have connection refused. All right, because our database is not connecting because we need to be having environment variables. All right, so to understand how to do this a little bit better, let's go over to our GitHub repo. I'm going to go to the main repo, and I'm going to look at the workflow. All right, so when we deployed this, you'll see that we used Docker run, and then we had 1, 2, 3, 4 environment variables. So we need to add these here. All right, so if I go up in Kubernetes and I look up environment variables deployment, let's see how we can do this. All right, so we can define environment variables for a container by adding the property env, and then it's going to just be a list of env variables. So let's go ahead and do that. We'll add this right after name, and then we can say env, and then we'll say name. I think it's db host, and then we'll say value, and then let's go over to RDS and grab our instance endpoint. This is our endpoint here. So just a note, we are putting this all into our GitHub repo. Or into our local repo, but we don't want to push any of this to GitHub because this has sensitive information in it. It's not the end of the world in terms of we're Terraform destroying, so that endpoint will likely change by the time anybody sees it. But regardless, you shouldn't be pushing secrets or anything sensitive to GitHub. So what we're going to do before we forget is we're going to add a .getignore file, and then we're going to add k8s/. So that way, if we say, let me open a new terminal, git status, you'll see that the only thing that it looks like we added is the getignore, and all of these files where sensitive data will be ignored. All right, and that will help so you don't accidentally forget. So now we have db username, and then the value is going to be Postgres, and then db password, and the value is also going to be Postgres. And then we have environment, and value is going to be production. All right, so now that we tried that, we can go back here and we can say kubectl apply -f deployment.yaml. Another option could have been that we could have done kubectl delete -f deployment.yaml, and that would have deleted all of the resources listed in that YAML file. And then you could have said kubectl create -f YAML deployment.yaml. So now let's go ahead and get our pods. See. All right, so it looks like it's not liking my apply very much. So let's go ahead and use the delete-f deployment.yaml. And then let's do k create deployment.yaml. Maybe because they were like aired in an aired state, it wasn't watching. All right, so now we have the status running, but just a heads up, if you don't have a health check, it's just automatically going to say running in the beginning. The only way to actually know whether or not it's ready is if you add a health check, which we will at some point, but more on that later. So now let's do k logs, and then we can just select a pod. Oh, and we got connection refused. Oh, because I'm being ridiculous. And I added these envs to the front end file. Silly me. Did anybody notice that? Message me in Slack if you did. All right, that's better. I was like, wait, why is this not working? All right, so let's go ahead and also explains why apply didn't work. So I guess the note then is if something's not working, okay, so see, that's working now. If something's not working and you're confused about why, and like don't just assume why, it might be that it's you and there's a problem. All right, so let's now clear, let's do kget pods and not watch, because that was a lot of the list. All right, and then let's go ahead and copy this so we can look at the logs. Also, you'll notice that, oh, perfect, we got started. You'll notice that I still mess up all the time, and I've done this hundreds of times. So like, don't get down on yourself if you don't get this right the first time or the second time or the third time. Typos are easy to make. Your brain can not be thinking clearly, all right? All right, so now that that seems like that's working, let's do get pods -o wide. All right, so now we have all of our pods. Let's go ahead and try to ping one of our backend things. So we're going to say k run temp pod --image nginx -rm -it -sh. Now let's say curl. Let's select one of the API pods. And we have to add the port at port 3000/API. /API is not, oh, curl at port 3000/API. Perfect, there we go. All right, so now let's take a look at our service.yaml file for our API. So we're still API version v1. We're still kind service, but we need to change all of these front ends to API. We're naming our service to do API service. The labels that we're adding to that service are app to do and tier API. And then the specification for the service, we will be selecting all pods that have app to do and tier API. That means that when I make a request to the to-do API service, it's going to send the request to a pod that has the same labels as app to do tier API. All right. In terms of ports, the port that my service will run on is 3000, and the port that my pod is running on is also 3000. All right. So let's go ahead and say k create -f service.yaml. And that was created. So let's say k get service to take a look at what's going on. All right, and you can see our services there. Let's go ahead and say k run temp pod --image nginx. And then we can say --rm -it -sh. we're creating a temporary Nginx pod so that way we can communicate with our server. So now we can say curl to do -API service at port 3000 /API, and we see our hello world. All right, so our service is working and our deployment is working, and now we have a deployed application. However, we have a deployed application that is within our only able to be seen or interacted with from within the cluster. So we need to figure out how do we actually access this application from the internet. And then we have some cleanup to do on our API Dockerfile, because right now you will see if we go into our API, we are running the migration and running the server in the same command, and it's going to be cleaner to separate that.
All right. So we have deployed our application within our cluster. Something I want to take a look at, though, is the database migration portion of the API. All right, if we go and open up our Dockerfile, we'll see that we are running a command for both running the migration and starting up the server. All right, that is doing a lot at once. Okay, so what we're actually going to do is we're going to kind of pull out this database migration, all right, into a job. A job is something that runs once or runs a certain amount of times, or you can either do something like a cron job where you run a job, you run a thing of work that you want the computer to do for you on a like cadence based on time. Okay, so maybe you want to add 2 + 2 every week. Okay, you can make a cron job that calculates what 2 + 2 is every week. All right, in our case, we want a job that's run when we run it, and we want to separate it, running the migration from the starting of the server. All right, so let's go ahead and take this out of our Dockerfile. All right, so we're going to say git status. I'm going to go ahead and open a new terminal to do this, though. Git status, git add, git commit. All right, and then removed migration from API Dockerfile. All right, removing this and turning this into a job allows us to run the migration when we want to and run the server when we want to, but not necessarily always be restricted by running them at the same time. All right, and it allows our server to start up a little bit faster because we don't have to wait for the migration to run every time. An example of that would be like, what if you change something on your database? So like instead of returning hello world from a route, you return hello world, how are you, right? That doesn't actually change. We don't need to make a change to the database for that. So there's no need to rerun the migration, just to deploy a new version of the API. All right. So we are going to create a new file in our API folder here, and we're going to call it database-migration-job.yaml. All right. Then what we're going to do is we're going to go over to the Kubernetes job page here, and we are going to read a little bit about it and get an example YAML file. So a job creates one or more pods and will continue to retry execution of the pods until a specified number of them successfully terminate. All right, so in ours, okay, we want one migration to be run. So it's going to create a pod using that API image. It's going to run the migration command, and then it's going to be done with the job. All right, and so the pod doesn't need to be running anymore. Okay. A simple case is to create one job object in order to reliably run one pod to completion. The job object will start a new pod if the first pod fails or is deleted. All right, so here is an example job. So we're going to go ahead and copy that YAML file and paste it in here. All right, so let's take a look. Once again, we have API version, kind, metadata, and spec. All right, so we'll leave batch/v1, we'll leave job as our kind, and for metadata, we will change the name of this to database migration job. All right. Now in our spec, we're going to define the specifications of the job. You'll see this template here again, and that template is going to be the template for the pod that it's going to create. All right, so in terms of container, I'm not going to do name. Let's go look at my deployment. Oh, I guess we did name it here. All right, so we'll call this database migration. And then we will change the image. We'll go over and grab our ECR repository URI here. And then we'll add latest at the end. And then in terms of the command, we want to run npm run migration run. All right. That's fine. We can leave restart policy never. And I'm going to go ahead and I guess we can take back off limit. Or let's have GitHub Copilot explain this. But my understanding right now, or my educated guess, is that after 4 tries of failing, it will stop trying to do this. All right. So it says the back off limit field specifies the number of retries for a job before it's considered to be failed. So I'm actually going to change this to 1. So it will retry it once, and then if it fails again, then we'll just say the job failed. Because if the database migration doesn't work after retrying it once, it's an us issue. All right, the next thing that we need is just like we needed the environment variables in our API, we need these environment variables in our container running the API for the database migration. All right. So I vote we just give this a shot and see how it goes. All right. So we are currently in the front end folder. Also, just a note, if in the last video I wasn't in the front end folder, now I am, it's because it's the next day and I'm recording this. So I actually spun up a new Terraform. I created a new infrastructure with all of our Terraform plans. All right, so let's go ahead and CD out of that folder and then into the API. All right, and then now we're going to say k create -f database migration job.yaml. Click enter, and our job was created. So now we can say k get pods. All right, and you can see that this said that the container was creating. So let's go ahead and instead say k get pods -w, so we'll watch it. And you can see that our database migration completed. And so now the container is no longer running inside of it because we completed the database migration. All right, so now if something changes to your application on the back end that doesn't have to do with the database, you can just go ahead and update your API deployment. If it does include a change to the database, then you could run the migration and also update your API. All right, so now we are finally on to the fun part, which is making sure our application is accessible from the internet. All right, so right now we have a cluster, but we just have service and pods, okay? So we have this portion of this graph. But what we can't do is, so yeah, if we're inside the cluster, we can hit the service, which then hits the pods. But if we're outside of the cluster, there's no way in, okay? So what we need to do is we need a resource called Ingress. All right, and Ingress is going to allow us to access the cluster, our application within the cluster, all right, through an Ingress managed load balancer, okay? So the Ingress resource is going to basically say all of our rules that we have for accessing the different services in our cluster. So that's where we would say those target groups and the rules around them. So we would say, all right, if I hit the root route, just slash, right? I want the user to be directed to the front end service, which then will direct the traffic to one of my front end pods. All right. But if I use the route slash API, okay, then instead of being directed to the front end service, my traffic will be directed to the API service, which then will be directed to one of the running API pods. All right. And so our Ingress resource is where we define this. All right. However, there are prerequisites. In order to create an Ingress resource, you have to have an Ingress controller. All right. If you just create this Ingress resource without the controller, then creating the resource will do nothing. If you have an Ingress controller, now that controller will sit there within your cluster and wait for your Ingress resource to be deployed. As soon as you create an Ingress resource, your controller will be like, oh, hey, look, here finally we have the rules for how to route traffic. Thank you. And then it will apply the rules. Okay. Kubernetes itself does not have Ingress controllers. Instead, there are third parties that have created Ingress controllers that you can then choose to use. I typically at work and here for my personal projects like the Coding with Kelly website used an application load balancer controller from AWS. All right, but that one is a little bit more complex to set up. So since we don't have all the time in the world, each of these challenges to do this, instead we are going to use the Nginx controller. All right, you can install the Nginx controller with a few different things. You can use Helm, which is something that we'll get into next week, or you can use kubectl apply with YAML manifest. It also looks like there's some add-ons if you're using Minikube or MicroK8s, but we're not doing that. Okay. So we're going to use the second option here. So basically, from this website here, we are going to get a bunch of YAML files with resources already described in them. And all we're going to do is we're going to use kubectl to apply all of those Kubernetes resources. And then that is going to make up our Ingress controller. So let's go ahead and go down to the quick start. You can see that that's the quick start for Helm. And then here is the quick start for Kubernetes. I'm going to go ahead and copy up this YAML file and put it in my browser so that way you can see all of the services. So this YAML file is just similar to how we have our YAML files, but we have a separate one for each of our resources. You can actually just create one big YAML file with all of your resources and Kubernetes will know what to do. So here are all of the different resources that we are going to be creating, all right, in order to get our Nginx Ingress controller up and running. All right, so now that we have that and took a look, we can go ahead and run the command. All right, so it's a little bit bigger. We'll say kubectl apply and then apply that YAML file. And you can see all of the resources that it is creating. All right. So now if we want to go and check to see how things are going and if everything deployed properly, we can run kubectl get pods -- namespace equals ingress nginx. Okay. And you can see that here is what was created in that namespace. All right. We have our Nginx controller that's running, and then it looks like we had 2 jobs that were completed. All right. Why did we add this -- namespace to our command? Well, in that big long YAML file that we saw, you'll see that the very first thing that they do is create a namespace. A namespace is a way to group your resources. So maybe you would have, so similar to how labels help us be able to search through things, namespaces separate and group resources. So that way we can kind of more easily see what we have going on. So maybe you have a namespace for environments, right? Maybe you have a dev namespace and then a QA namespace or a prod namespace. Sure, you could do labels for all of those, but a namespace, as you get bigger and bigger in terms of like how many applications you're deploying, namespaces will help. Okay. So this is helpful to us because if we go ahead and say get pods spelled correctly, you'll see that none of the Ingress controller is going to pop up, and we're able to just kind of see the pods that we want to see, right? But if we want to see the Ingress pods, then we either have to do this -- namespace equals, or we can do -- namespace space, or we can do -n, which is the shortcut for namespace. All right, since this is running, then I'm going to say that we're probably pretty good. So the next thing that I'm going to do is I'm going to try to log or look at the logs for this controller, and then we'll create an ingress and look at the logs again. All right, so you can see, oh, we have to add on, by the way, anytime that you're trying to request something from a namespace that's not default, you have to add the -n or -- namespace on. So ingress -nginx in order to get it. All right, so you can see all right, so nothing. All right, nothing too crazy so far. So let's go ahead and figure out how we create our ingress resource. All right, so we are going to go down here and we're going to copy this minimal ingress. Because the ingress is something that works for the API and the front end at the same time, we're just going to create this resource outside of the API and front end folders. So we're going to say ingress.yaml and then paste this in. All right. So API kind, metadata, and spec once again. We'll leave the API version in kind and we'll change the name. We're going to change this to do ingress. All right. We are not going to use this annotation. So basically what this annotation does is it says that when we hit, in this example, this test path, okay, it's going to rewrite it's going to direct us to the test service, and then it's going to remove this test path. All right, so that would be helpful if like your API didn't have the test path global prefix, because you could still say like, hey, hit my API service with /API. But once you get into the service and you request something from the pods, drop the API because my pods don't know that it should have an API. All right, so we don't actually need that because we do have a global prefix, so we're going to get out of that. For Ingress class name, we're just going to use Nginx, and this is how we tell in the app. This is how we denote to the controller, like, hey, I am an ingress for you, because you might have multiple controllers, so you need to define which controller kind of goes with which ingress YAML file, which isn't really an issue for us because we just have one and one, but still, all right, it's still mandatory. All right, so now rules. When we get HTTP traffic, all right, we are going to have two paths. The first path that we're going to have is just this root path, okay? And it is going to send us to the service front end to do service at port 80. All right, so now let's copy this, paste it in, and now we're going to have at /API. We want it to be sent to the API to do service, and that is going to be at port 3000. All right. So let's go and look at our EC2 where our load balancers are and see what's happening so far. You can see that we have load balancer 1, and that's not something that we created ourselves in the console or through Terraform, but this is what was created when we ran this kubectl file in order to get our ingress controller. So if you look right now, when I hit it, we don't have an ingress, right? We don't have any rules defined as to what to do with that traffic. So we're just getting this 404 not found Nginx error. All right. So now let's back out of the API folder. We're just back into the K8s folder. Let's ls, and you can see that we have our ingress.yaml. So let's say k create-f ingress.yaml. And our ingress was created. All right. So now, all right, well, we have a different error. Service temporarily unavailable. I'm curious if it's just because we went too quickly, but let's go ahead and I'm going to make this a little bit bigger so we can see better. Let's go back to our, let's actually just view the logs. All right. So you can see that we have some more logs coming in. All right. You can see that a new configuration was detected. All right. Now it says errors obtaining endpoints for service, front end to do service. Oh, no object matching. It's because I used the wrong thing, right? Because it's to do dash front end service and then to do dash API service. Come on, guys. Why don't you tell me? Which is a joke because there's no one listening to me right now. All right, so we have to k delete dash f ingress.yaml, then k create dash f ingress.yaml. All right, and then k get pods. Nope, we don't need to get pods. Now let's go back and look at our logs. All right. Successfully reloaded. All right, so this is the issue we had before. Reload triggered because of change of configuration. Oh, here we have more front end to do service doesn't exist. So these are hard to read if anybody else is struggling with me. All right. Kind pod successfully validated configuration. That feels good. Found valid Ingress class, which is this thing that we were talking about. All right, this feels good. So let's refresh and whoop, whoop, whoop. We see our React front end. So let's say deploy to EKS. Let's write the description. This is so fun. And we have it. So that means our database and our API is working too. Let's mark complete. All right. So we successfully deployed a full stack application and we've done a pretty good job. All right. So we are going to go ahead and tear everything down. I will note, though, that we created the migration and we ran it, but we didn't really have a migration like in the chamber running. So I think it would be a really good activity to add on, make a change to the database and the code, practice redeploying, look more into Kubernetes stuff, and practice like spinning up and tearing down. I'm not going to do it in here because at this point you have all of the tools and the pieces of the puzzle, and I trust that you guys can kind of figure out what to learn next. But I have had some problems tearing things down, so I'm going to try with you guys to tear it down. All right, so the first thing I'm going to do is I'm going to grab that YAML file again, and I'm going to say kubectl delete-f. And then I'm going to delete all of these resources. The reason why is we created all of our infrastructure with Terraform with the exception of this load balancer. All right, and I've had some issues when I'm trying to delete the load balancer because the load balancer had some security groups with it and such. So my Terraform destroy did not work. All right, so the first thing to do is go ahead and run kubectl delete-f. and then all of our controller resources. The next thing that we'll do is just the normal Terraform destroy. I'm actually going to go find the correct one command so I don't have to type out that var-file. All right, and then I'm going to just pause and let it go ahead and destroy for me, but I will kind of check back in. Either we successfully destroy everything and yay, or we have to troubleshoot still, and deleting this with kubectl wasn't the full response. But either way, I'll be back in a few minutes. All right, we successfully destroyed all of our resources. So moral of the story is please use kubectl delete-f and then this file URL in order to delete your load balancer. And then once you do that, you can go over here and destroy your Terraform. All right, and with that, that concludes week 9 of the Deploy in Public Challenge. I'll see you in the next one.